like geometry at all over it, I assure you. Yes. You're in honors pre-calc. It's going to be harder than geometry. All right, so Chapter 7 is where we start our trig. This trig carries through for pretty much the rest of this quarter, till the final exam. The entire second quarter really revolves around trig. Trigonometry, trigonometric functions, measures of angles. Trigonometry means triangle measurement. This is all about angles in this first section. And how do you name them? How do you measure them? What are the ways we use to measure angles? How can we be more exact and more specific? When we look at an angle, and we talk about an angle measurement, in general, we talk about this being the initial side, and the vertex of the angle, we're going to measure from what I term horizontal right. So the angles here, this is horizontal right, is the, bless you, it is the initial side, the initial ray, it's where the angle starts. Angles are measured in a counterclockwise direction from horizontal right to a terminal side, a terminal ray of the angle. In general, the variable we use for angle measurement is theta. It's Theta. I am not saying theta with an F. I'm saying theta with a TH. This is the symbol for theta, not to be confused with this symbol for no solution or empty set. Okay, this is not what I want to see. I want to see a circle, a zero, with a horizontal line through it. It doesn't come out of it. It looks just like this. That's how we write the Greek letter theta. Pay attention to the details. Right? You do not want to get run over by the details in this chapter. And if you get all this new information today, go home, put it on a flashcard or rewrite your notes, study them, but come in tomorrow having this stuff wired. 1 degree is 1/360th of a circle. 1/360th of the revolution of a circle is 1 degree. And that's one way we measure angles. This means 1 minute. 1 minute is equal to 1/60th of a degree. So if you can imagine an angle that is 1 degree in measurement, and then you take that angle and slice it into 60 different parts, 60 equal slices, each of those slices is called a minute. And this is where we're talking about getting considerably more accurate. So 1 degree is equal to 60 minutes. In 1 minute, if you can imagine taking one of these 60 slices from the degree and slicing that into 60 slices, those slices will be called seconds. Okay? So 1 minute is equal to 60 seconds. So 1 mark here, 1 hash mark, 6 is a minute, and it's equal to 60 seconds. 2 hash marks mean seconds. If there's 60 seconds in a minute and 60 minutes in a degree, there's 3,600 seconds in 1 degree. So if you can imagine taking this 1 degree and slicing it into 3,600 slices, those slices are seconds. Why do we need to have such ridiculously small measurements? One of the big things is when you talk about angle measurements as direction with vectors and that type of thing, right here, when we're measuring an angle that's from here to here, 3,600 seconds, it doesn't make that much difference to us. But if you can imagine taking a 1-degree angle and sending it off to space a bazillion miles away, and you're trying to send a unmanned object, whatever it is, to another planet, if you just measure by degrees, you have to realize that as you go out a bazillion miles, the distance between these two terminal and initial sides becomes quite large. And you're going to miss your target potentially. When you get down into minutes and seconds, you can become significantly more accurate. So an example of an angle, 36 degrees, 48 minutes, 12 seconds. So one little tick mark is minutes, 2 little tick marks is seconds. Seconds are pretty small. So when we look at angles, you're going to find out that there are angles, large angles, that have more than 360 degrees in their measurement. Means you're talking about multiple revolutions from your initial side. Remember, we're going to start at horizontal right, and we're going to go counterclockwise. So if you have angles more than 1 revolution, 1,000 degrees. That means we start here, we go all the way around once, all the way around twice, and almost all the way around a 3rd time. Smaller angles, between 0 and 360 degrees, is less than 1 revolution. 1 revolution is 360 degrees. Remember that you always are going to start from horizontal right and go counterclockwise. Counterclockwise is your positive direction. Counterclockwise is the positive direction. If you go clockwise, you're going in a negative direction. And just a little side note right now, negative angles are bad. Almost always, if your answer is a negative angle, you can go put a little line through it and put -1. Because I'm going to take a point off. You are not permitted to give negative angles. Usually. There are exceptions. So, 2 ways to notate for me angle measurements. Degrees, minutes, and seconds, DMS, or decimal degrees, DD. You need to be able to convert both directions, from decimals to degrees, minutes, seconds, and from degrees, minutes, seconds to decimals. It's not a difficult computation, it's tedious. You just have to be meticulous. Many of you wear that lazy t-shirt, I did it in my head t-shirt, I don't need to show you work t-shirt. You have to show the work. The details are important in this chapter. All of a sudden, I came up with an answer, poof, it's not going to get you the points. So I need to be upfront with you. There are conversions on graphing calculators and on scientific calculators that will convert 12.31 degrees into degrees, minutes, seconds. You're welcome to use them. I'm just not going to give you any points. I'm not going to give you partial credit. I'm going to give you no credit. I don't mean to be ambiguous here. There is no partial credit when you don't show the work. There's no credit. If I want to turn this into blank degrees, blank minutes, and blank seconds, which part of the decimal degree is the issue? The 0.31. How many degrees do we have so far? Well, we have for sure 12. There's no mystery there. So you're really going to subtract the 12 degrees. It's the 0.31 that is our issue. 0.31 degrees. How do we change that to minutes? What's the conversion to change 0.31 degrees into a certain number of minutes? Just simple times by 60. Now, 0.31 degrees times 60, how much do you get? Holy cow. 18.6. We need decimals. So 18.6 is what? 18.6 minutes. So this is now minutes. So that means we have 12 degrees. We have 18 minutes. If you subtract your 18 minutes, you're left with 0.6 minutes. We want to turn the 0.6 minutes into seconds. How do we change a minute into seconds? Multiply by 60 again. And 60 times 0.6 is 36. So 36 seconds. 12 degrees, 18 minutes, 36 seconds. It is a very simple conversion. You multiply the decimal part by 60 from the degrees to get minutes. Multiply the decimal part of minutes by 60 to get seconds. If need be, you round to the nearest second. So if you don't get a nice pretty 36 seconds, you get a decimal here, round to the nearest second. See if you can do the 2526. See if you can convert that back into degrees only, decimal degrees. All right, so what do we do first? What do you do first? Daniel?
Divide seconds by.
So you take the 6 seconds divided by 60, and that gives you what decimal? 0.1. So that means that you have 25 degrees in 20.1 minutes now. How do we handle the 20.1 minutes? Which part? The 20.1. So 20.1 divided by 60. What does that give you for your decimal? 335. So that means you have 25.335 degrees. Does that make sense to everybody? Okay, change the degrees to, bless you, degrees, minutes, seconds. Change the degrees to degrees, minutes, seconds. Okay, so what do we do with the 0.78? Okay, so we're multiplying by 60 now. And what do you get when you multiply by 60? 46.8 exactly. And that's what measurement? That's the minutes. So this will be 46 minutes. Take away the 46 and just look at the 0.8 minutes. Times that by 60, and how many seconds is that? 48 seconds. Okay. The conversions are easy and they're fast. Don't look for this to be complicated. It's not. We're not trying to make it complicated. Now, this unit of measure, maybe you've been exposed to it, maybe you haven't, I don't know. But this unit of measure is a different way to measure angles, and this measurement is called radian measurement. A radian is a different unit of measure. By definition, there are 2 pi radians in 1 revolution. And you'll see, I'll talk more about that in a minute. A radian measurement, you're looking at something quite a bit different. And a radian measure is arc length. The variable we use for arc length is S divided by radius, which is R. And the radian measurement, the measure of an angle in general, is theta. Theta is equal to S over R. Or arc length is equal to theta times r. So this formula right here, arc length S equals theta times r, this formula is a valuable formula and pops up periodically for the rest of this quarter. Okay. R is the radius, S is the length of the arc, in other words, it's part of a circumference. Theta is the angle measurement. Again, it's going in a counterclockwise direction from horizontal right. Radian measurement is very different from angle measurement. On your calculators, you will find, and we'll talk about this, that there are two measurements that you can use on your angles, and one is radians, one is degrees, and it is imperative that you set your calculator in degrees or radians depending upon which you're going to use. So very important that we know what we're talking about. One revolution in degrees, 360 degrees. One revolution in radians is 2 pi r, which means there's 2 pi radians. We have 2 pi radians in one revolution. If you divide these, since they're both one revolution, if you divide them both by 2, that means that 180 degrees is equal to pi radians. 180 degrees is equal to pi radians. If you want to know what 1 degree is in terms of a radian, we divide both sides by 180, so 1 degree equals pi over 180. And if you want to know what 1 radian is equal to in terms of degrees, you divide both sides of the equation by pi, and 180 over pi is 1 radian. Remember, 360 degrees and 2 pi are equivalent. You can always start with that and then solve for either 1 radian or 1 degree. If that's true, to convert from degrees to radians, you're going to multiply the degrees by pi over 180. To convert from degrees to radians, you multiply by pi over 180. Pi is a variable that stands for the circumference of a circle divided by the diameter. It is not 3.14. Don't use the decimal. Leave it in terms of pi unless I ask for some reason for you to use the pi button. If you're going to convert from radians to degrees, you're going to multiply by 180 over pi. Again, we are all about being exact, so we do not want an approximate. We typically don't want the approximate. We want to know that it's 3 pi over 2 radians. We want to know that it's pi over 6 radians, pi over 3 radians, 5 pi over 3 radians. You want to have exact values, so we will not be substituting in for pi. One revolution is 2 pi or 360 degrees. Now, you guys have skated with labels for a long time. When you answer a question, what's the total area, and you say that it's 25, that's not really correct. You should have 25 square feet, 25 square inches, something along those lines. It is imperative when you want your angle measurement to be in degrees that you have a degree symbol. Because if you write the number 28 as the measure of your angle, it is understood that that 28 is radians. If your angle measurement is 28, you've just told me that the angle is 28 radians. If you mean for it to be degrees, you need the degree symbol. We don't really have a symbol that we use for radians. Remember, 1 radian, 180 over pi degrees. And 1 degree is pi over 180 degrees. Those are your conversions. I feel like all of this stuff is informational, but if you're not understanding something, you got to ask. Don't let it get too far, because we're just going to keep pounding you with more and more and more and more. Right?
I have a question on the last
This
one.
one?
Yeah, why have theta?
Theta is what we always will use as our unknown angle measure. So when you're looking, you've spent really probably the last 4 or 5 years focused with algebra, right? Even in our class, the first half, a lot of algebra. What's our favorite variable? X. X is our algebraic missing side, missing this, missing that, missing number. X is the way we go. Whenever we talk about angles, we typically use these Greek letters, and we usually, if we only have one, theta is the most common angle that we use for an unknown. But this is a variable. Now, so we're talking about 1 revolution, theta is 2 pi, theta is 360. In a half revolution, theta would be pi or 180 degrees. Okay, so theta is just really how we're going to measure our unknown angle. We just say, oh, we'll call it theta. Okay, so again, converting from radians to degrees and degrees to radians. So here's 196 degrees and 1.35 radians. How do I convert 196 degrees into radians? What do you multiply by? Pi over 180. Okay? So 196 times pi divided by 180. I do not want a decimal for this. So we're going to have 196 over 180 pi. And what do you need to do with that? Simplify, reduce it. 49 over 45. 49 45ths pi. Everyone following that? What if you're going the other way? You want to multiply, or you want to take 1.35 radians, and you want to change it to degrees. What are we going to multiply 1.35 by? 180 over pi. So what's 1.35 times 180? 243 exactly. So 243 over pi degrees. In 2.5 pi radians, what are you going to multiply the 2.5 pi by? Over pi. So when you have this situation, the pi's cancel. And what's 2.5 times 180? 450. And make sure you get in the habit of putting the degree symbol. Don't need the degree symbol on this one because you're filling in the blank and it says 450 degrees. But I really recommend that you do that. So this one right here, degrees. This one right here, degrees. Okay, try these two. 180 over pi. Pi over 180. Flip a coin. It's got to be one of them, right? 233.23 pi over 180. 233.23, you're going to have to divide by 180. You're going to have to go decimal on this. You don't have a choice. You're in decimal form here. You can't leave a decimal divided by 180, so you're going to have to get a decimal. What does that become? 1.296.5. many decimal places? 3. The only exceptions are money, which is an application, and other applications. You can't have a decimal of a person type. What are we multiplying the 11 pi over 6 by? 180 over pi. The pi's canceled. The 6 into 180 is 30. So how many degrees is this going to be? 330. If you give me an answer like this, you're going to get a point off. What's wrong with it? It's got to be in degrees. You've got to tell me it's degrees. Either the word or the symbol. It's an easy mistake to make. It's a bad habit that you've developed. You don't label. You got to label now. This link right here, I'll post the notes and all of that, but this link takes you to some pretty good review right here. Okay, there's a variety of different things in here that we're talking about today: radians to degrees, degrees to radians, the multiples of pi, coterminal angles. This is a pretty good web page, and there's other stuff as well in this. When you go back to the topics, there's other things in this web page that may prove to be beneficial to you in this next couple of chapters. So this is a pretty good source. And again, I'll post the notes online, so if you don't want to copy down the source right now, that's fine. All you really need is themathpage.com, and that'll give you the things that you're looking for in terms of concepts that you want. So this is a pretty good resource. Okay, so now this page looks busy, and it looks like there's a lot on there, because there is. There is a lot of information on here that are very, very important. What we want to get used to is talking about the different kinds of angles. And we have up here a variety of terms that we want to talk to. The first one I'm going to talk about are quadrantal angles. A quadrantal angle means that the terminal side of your angle is on the x or y axis. The terminal side is on the x or y axis. Remember, the initial side is always going to be horizontal right. We're always going to be using horizontal right. So if we talk about 0 degrees, that has a terminal side on the x-axis. That's a quadrantal angle. The next would be 90 degrees. The next, 180 degrees, 270 degrees, and 360. Those are all what we call quadrantal angles in degrees. When we talk about quadrantal angles in radians, remember, all the way around is how far in radians? About 3, 2 pi. So all the way around is 2 pi. So 2 pi radians would be a quadrantal angle. 0 radians is a quadrantal angle. If 2 pi is all the way around, how much is halfway? 1 pi. So pi radians, also quadrantal. Half of pi would be a quarter way around, pi over 2 radians, in green. And 3/4 of the way around will be 3 pi over 2 radians. Now remember, degrees, radians, you've got to put the labels on. But remember, there's lots of ways that we can identify this angle measurement, where you have the terminal side right here. Coterminal angles. Okay? Coterminal means they share the same terminal location. They have the same terminal side. Coterminal angles have the same terminal side, but we're talking about multiple revolutions. So when we look right here on the green, pi over 2 radians. If I were to go to that terminal side and then go all the way around again, you would add 2 pi radians, you'd have 5 pi over 2 radians. Same location. If you go around again, you'd be at 9 pi over 2 radians. If you went backwards, this red angle, negative, you went 3/4 of the way around negatively, that would be negative 3 pi over 2, same terminal side. Those angles that have the same terminal side are called coterminal angles. So pi over 2, 5 pi over 2, 9 pi over 2, negative 3 pi over 2, all are considered to be coterminal. They have the same terminal side right here. If you want to find out a coterminal angle, add 2 pi. You can add 2 pi forever. Pi over 2 plus 2 pi, or 4 pi over 2 is 5 pi over 2. In radians, angles with the same terminal side can be found by taking theta plus 2 pi times n, where n is an integer. Theta plus 2 pi n. If you add 2 pi once, or twice, or 3 times, or 4 times, that's what n is. How many more times around do you want to go? In degrees, angle with the same terminal side are found by adding 360 n times. Theta plus 360 n, where n is an integer, add 360 once, twice, 3 times. So if you looked at this angle right here, 90 degrees, add 360, you'd be at 450. You could subtract 360, like n is negative 1, 90 minus 360 would be negative 270. And you can continue to add and subtract 360, and you'll get other coterminal angles. Coterminal angles are not just at the quadrantal angles. You can do this with any angle. 30 degrees plus 360 is 390 degrees. 30 and 390 are 1 revolution apart. Okay? If you envision running around a track and one person goes around a certain distance and another person goes that same distance and then goes all the way around again and you're both stopped, you're standing at the same place. The second person went all the way around to get back to where you are. So they went further, but nonetheless your terminal where you stop, same location. Quadrantals have to be on the axis. Coterminal just has to stop in the same place. All of these terms, all of these details, you want to make sure you're clear on them. In quadrant 1, okay, in quadrant 1, in quadrant 1, well, up here, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Our most important quadrant is quadrant 1. Okay? And in quadrant 1, we have what we call bless you. We get our reference angles. Any angle that is in quadrant 1 in the first revolution is called a reference angle. Okay? And these are the angles that you're going to want to memorize. You're going to want to memorize their trig values, the trig ratios for those angles in that quadrant. And then you're going to want to be able to take those angles and go out and say, well, how do they relate to our other quadrants? What do we call an unknown angle? Theta. So we're going to take and say, here's our unknown angle in quadrant 1. We're going to call it theta. Now we're going to work in degrees first, and then we'll go back and talk about radians. but it's easier to work in degrees. This is 0 degrees, or 360 degrees. This is 180 degrees. The reference angle is important because there are 3 other angles in this first revolution that are related to theta, and they occur in the other 3 quadrants. So we get an angle in quadrant 2 that's related to theta. The measure of this angle in quadrant 2, this is 180. This angle right here, not horizontal right, but right here, this angle with the blue and this angle right here, the terminal side at 180, that angle has the same measure as this angle in quadrant 1. The angle that we're talking about in quadrant 2 is this angle. The terminal side is the blue ray, and the angle starts at horizontal right and is measured counterclockwise to get to here. What's the measure of that angle? The blue angle in quadrant 2.
180 minus theta.
180 back up theta degrees. Very good. Now, every angle that we talk about in the other quadrants, it will always, always, always be measured from the horizontal. You never say, well, it's 90 plus something, or 270 plus or minus something. It doesn't work that way. It always comes off of the horizontal. In quadrant 1, you're up theta. In quadrant 2, you go back theta from 180, 180 minus theta. When you go to quadrant 3, this is still theta degrees. Right here, that angle right here is still theta. But the angle we're talking about in quadrant 3 is this angle. Starts at horizontal right, goes all the way to here. What's the measure of that angle? 180 plus theta. And then your angle in quadrant 4, again, this would be theta right here. The measure between these 2 angles would be theta degrees. The angle we're talking about in quadrant 4, however, is this angle. What is the measure of that angle? Right, from the horizontal, we're going to go from 360, we're going to go back theta, 360 minus theta degrees. That is how you're going to find the other angles in quadrants 2, 3, and 4 when you know your reference theta. If this is also pi radians, the measure of this angle in radians is going to be pi minus theta. In quadrant 3, it's going to be pi plus theta. And in quadrant 4, what's 360? 2 pi. So we're going to be 2 pi minus theta. And those are radian measures. If theta is in radians, that's how you get to quadrants 1, 2, and 3, or quadrants 2, 3, and 4. Everybody good on that? So again, we talk about standard position. That means horizontal right, counterclockwise. What does coterminal mean? They end or share the same terminal side. They end at the same ray. Positive angles go in which direction? Counterclockwise. Negative angles go clockwise. quadrantal angles have to have a terminal side, X or Y axis. And it doesn't matter which direction you're going, they can be positive, they can be negative, but they have to end on the X or Y axis. You're going to see a lot of this picture in the next 6 or 8 weeks or whatever it is that we work on this trig stuff. This picture kind of talks about what we refer to as the unit circle, although it's not labeled as such. It will be in the future. Right now it's only labeled for you to see angle measurements. These angles are measured how? Radians. Okay? How do you know that they're in radians? Because there's no degree sign. Do not fall for that trick. Just because you see a pi doesn't mean that you're in radians. Because if I tell you, hey, you know, let's do pi over, or let's do 20 pi over 3 degrees. We're talking about 20 pi over 3 degrees. All right? You're looking at somewhere around 20 degrees. But you're in degrees. It just happens to have pi in it as well. All right? This angle right here is pi over 6, pi over 4, pi over 3. You are going to want to have these ones memorized. This is 30 degrees. This is 45 degrees. And this is 60 degrees. Now, you're going to want to learn radians. You're not going to want to always have to convert these. Converting is not really a good thing. And the coordinates in quadrant 4 are positive, negative. So plus plus in quadrant 1, minus plus quadrant 2, both negative in quadrant 3, and positive negative in quadrant 4. Those are the coordinates of any point in those coordinates. So that means the coordinates of the points on this circle would have to adhere to those signs, positive, positive, for everything on the circle in quadrant 1. This is the same picture listed in degrees. 30, 45, and 60. These are your big 3 angles. Those are the 3 most important angles that we have that are not quadrantal. How do we get to the angles in quadrant 2? Same thing. This is 180 minus 30, 180 minus 45, and 180 minus 60. These are all related to these 3 angles. What do you call them in quadrant 1? Reference angles. Your reference theta in quadrant 1, 30, 45, 60. Or in radians, pi over 6, pi over 4, and pi over 3. Those are your reference angles, and you want to know them inside and out. You can always extrapolate to quadrants 2, 3, and 4 as long as you know the 3 in quadrant 1. Okay? So radians and degrees, you're going to want to figure these things out. Find 2 angles, one positive, one negative, that are coterminal with pi over 4. Pi over 4 is right here. Pi over 4 is halfway through quadrant 1. Its angle measurement in degrees is 45. Tell me another angle that's coterminal with pi over 4. What's another angle that's coterminal with pi over 4? 9 pi over 4. How do you find that? Plus 2 pi. So that means that 9 pi over 4. What does the angle look like? It looks like this. It's all the way around once, and then up pi over 4 from the 1 revolution. Or up pi over 4, and then 1 more time around. So we go up to pi over 4, and then 1 complete revolution of 2 pi. What would a negative angle that's coterminal with this look like? What's the negative one going to look like? Is a measurement. Not really complicated. Don't make it complicated. What is it? Negative 7 over 8. Negative 7 pi over 4. Okay? How do you get it? Minus 2 pi from 1 pi over 4 is going to be minus 8 pi over 4, or negative 7 pi over 4. The angle would look like this. Whoops. The angle would look like this. It's terminal at the same location. You can continually add 2 pi or subtract 2 pi to get other angles at the same terminal ray. This is our terminal ray. Are these the only correct answers? No. 17 pi over 4, 25 pi over 4, just keep adding 8 pi over 4. Or subtracting. Minus 15 pi over 4, etc. All you need to be able to find is one. One positive, one negative. Who's coterminal with 225? Positive. With a positive that's coterminal with 225. 585. What's a negative? Negative 135. Where are these angles? This is 225. This is 585. And this is negative 135. Constantly looking at terminology. This is all about details. We're in degrees. We're in radians. Which one are you dealing with? That's what determines how you behave here. Here's your list. Quadrantal angles. 0, 90, 180, 270, 360. 0, pi over 2, pi, 3 pi over 2, and 2 pi. In quadrant 1, your reference angles, they're going to come in families. So your quadrant 1 reference theta, 30 degrees or pi over 6. 30 degrees is related to 150, 210, and 330. Pi over 6 is related to 5 pi over 6, 7 pi over 6, and 11 pi over 6. These four angles, are related. The reference one is in quadrant 1, 30 degrees. The 45 degree family, or pi over 4, in quadrant 1. 135, 225, 315, and in radians, 3 pi over 4, 5 pi over 4, and 7 pi over 4. If you don't know these, they're easy to find. How do you find the angle in quadrant 2? In degrees. It's back in your notes about 5 slides ago. How do you find an angle in quadrant 2? In degrees. You know your reference theta. 180 minus theta. Theta is your reference angle. 180 minus 45, 135. How do we go to quadrant 3? 180 plus theta. 180 plus 45, 225, and 360 minus 45, or 360 minus theta is quadrant 4. So, do we really need to memorize these ones? No, we can generate them very quickly. We really need to know quadrant 1. 60 degrees or pi over 3. 180 plus 60, 180 plus 60 is quadrant 3. 180 minus 60, quadrant 2. And 360 minus 60 gives you quadrant 4. So we can always get that information by kind of following just our general pattern. Remember, this one right here, 180 minus theta, 180 plus theta, and 360 minus theta. Okay, that's how we're going to get from quadrant 1 reference angles into quadrants 2, 3, and 4. This is very important right here. There's a lot of information from today, folks. You're starting here at homework number 1.